All right, so let's finally discuss packing density and refresh rates, because this is where you really start to maximize your cost per part when it comes to SLS. So we touched on this earlier, but to recap, refresh rate is the minimum ratio of fresh powder that's mixed into used powder for continued printing and to retain the material's mechanical properties. So the recommended refresh rate depends on the material that you're using and whether you're printing in air or using nitrogen. Nitrogen can improve the dimensional accuracy, but it doesn't necessarily significantly affect the material properties or even the print success. So generally nylon 12 is our most popular powder, and it's what we typically use, so I'll focus on that going forward. It has great material properties, great physical properties, and it has a really good refresh rate even in air. So we'll stick with a 30% refresh rate for the rest of our discussion as well. And a lot of SLS printers require manual measuring and mixing of new powders to used powders. But fortunately, we have the SIFT and it manages that for us. There's an interface built in, and we can select our desired refresh rate, and the machine will automatically dispense the appropriate amount of powder, and then you can mix it using the machine as well. So here's a quick clip to give you a look at what that process looks like in this. And so this is where it mixes. We've got our used hopper on the left and our new hopper on the right. So this is our new powder coming in. It drops into a cartridge. We mix it in this cartridge using a mixer on the side of the SIFT, and then we move it back over to the printer for use in the future. So packing density is relatively straightforward at a glance, but it can be a commonly overlooked characteristic when it comes to SLS, and it can get a little bit confusing because of the variability. So I'll spend a little bit of time here. And so off the bat, packing density is the percentage of fused part in a build relative to the total amount of powder used. So basically the percentage of part to powder in a build chamber. And when it comes to the fuse, our ideal packing density is an average of at least 30% part to 70% powder. If that number looks familiar, there's a reason, and it's because that number is, we really want it to at least match our refresh rate, because if we're using 30% of the powder in the chamber, that 30% is being replaced with new powder, and if we're using more than 30%, it's even better because we'll end up with an even higher refresh rate. So we've got lots of fresh material mixed in with the used. And if that's confusing, that's great because it justifies the embarrassing amount of time I spent on these next few slides. So let's visualize this process just to make sure we all get it. So here we've got our fuse on the left, which is full of fresh powder. We've got 10 blocks here, so each block represents 10% of our volume. And on the right side, we've got some representations for our used powder hopper and the fresh powder hopper within the SIFT. So let's kick off a print that has a 30% packing density. So we heat it up, and now we have our fused powder in yellow in red, and then we have our used powder in yellow. So we take this over to the SIFT, we get our parts out, and we're happy with those. We take them away for the blast, but we end up with this amount of used powder in the used powder hopper, which is fine. We're going to use our 30% refresh rate, and we're going to be able to use all of our used powder each time we go through this build. So another quick example using 50%, same process. We've got our parts out, and now we're only partially able to fill the used powder hopper. And if we were to use that same 30% refresh rate, we actually wouldn't be able to fully fill the SIFT the next time, but that's totally fine. We can either use a 50% refresh rate, or we can do our 30 and then just top it off with fully fresh powder. The problem is when you start to get to those really low packing densities. So this would be a really big part, or a couple of like awkwardly shaped parts that are maybe like hollow on the inside. And so the problem that we run into, we'll be able to visualize here. So we heat up this entire chamber, and we only have a little bit of parts that we're able to get out of it. And now we have a huge amount of powder, used powder in our hopper. And when we go to refresh it, that's fine. We have just a little bit left over in our used powder hopper, which again is totally fine. But if you keep going this way, you're going to end up with a lot of extra powder. So as you can see, it just keeps growing. And in the worst case scenario, It increases our cost per part because this eventually might just become waste powder that we dispose of. So we just have to absorb that into our cost per part. But there are a few things that you can do here. And the first thing is you can try to find other smaller parts to pack into that build. So with SLS, you can nest parts inside of each other or push them right up against each other. They really only need to be about 1 millimeter distance between parts. So that's one option. The next thing you can do is offset this by coming up with a really high packing density build. So this one may only be 10%, but if we have some builds in the future that are 50 or 60%, our used powder supply is going to balance out, and that's no problem. So the next thing you can do is store up a bunch of this used powder and then save it for a prototyping build. So with nitrogen, we've seen builds as low as 0% refresh, and in air, we've seen as low as 10% refresh, where you may have a slight reduction in your part quality and your physical properties, but you can still have a part in your hand for fit and function. And then there is one last option, and this one's pretty convenient. It's that you don't have to spend as much time in the SIFT. So where you might normally spend 10 minutes sifting and trying to get all the media off, or all the powder off so you can reclaim it, now you only need a few minutes in the SIFT, and then you can let the blast do the rest of the work, which works out perfectly because the blast has an automatic powder separation. So that keeps your blasting media from degrading by being totally saturated with printing powder. And then later on, you can just dispose of that excess powder. And again, you can sort of absorb that into your cost per part. So it's really not the end of the world to end up with a low packing density, but it is something to keep in mind as you're laying out builds for the fuse. And that's a great segue into our next topic. How do you know what your packing density is, and how do you maximize it? Well, that all happens on the software side. So let's take a look at a couple of example builds, and I'll show you what parts are a great fit for this system and how you can use the tools in the software to set up hundreds of parts in a really high packing density with just a few clicks.